Okay, let's do some Wi-Fi. We will start out with the built-ins that come with MicroPython. Then once we've got that, then we'll look at some libraries that help us do, some more work, some real work. Okay, so we'll start out basic and then we'll move to more advanced things. So we'll connect to the internet, we'll pull some data down off the internet, maybe connect up to the YouTube API, get some data from there. Then we'll set up a server, a basic server, and then we'll set up an advanced server that actually lets us do some real work, that will parse data, let us do real work. So we can actually run, I've been running the hammered dulcimer with a server, so we'll do that. So we'll start basic, we'll move to more advanced. Now if you haven't seen the other video about how to set up your ESP32 module, how to load documents or load your scripts on there, then go and look at that. I'm just going to assume that you've got your module all set up and you know how to load scripts. So let's go. Let's get started. Let's see what the hardware is. Okay, we're using about the exact same setup as we did for the first video. Okay, so we've just got our module here, and then here's the ESP32 right there. And there's our Wi-Fi antenna, and then of course we got this can, which is a Faraday cage that keeps all the radio frequency interference away from the chips in there, or actually keeps it from coming out. Okay, we got this resistor just to keep the battery charge light off, and then the new thing that we have is this little beeper. Okay, and we're going to use that when we fool around with this thing for indicating. Alright, so it'll play a little, see what we can. Okay, so we've got a little beeper, actually it's called beeper, it's a script that we're using, which it'll be with the software, but that's what we'll use for indicating. We'll probably use the LED too. Okay, so just your basic setup. Now I do have a 100 ohm resistor to keep this thing from drawing too much current. Okay, so it's just coming off the 12 pin to there, into there, through there, to the resistor, bus, back to ground. That's all it is. Be just like if you hooked up an LED. It'd be about the same thing. So, okay, that's about it for hardware. All right, now let's do some coding. Okay, let's have a look at the scripts we're going to be using. So we've got boot and main right there, which you should know what those are from the last video. In this case, boot is empty. Okay, there's nothing here because we're not going to do, we'll do everything by hand as far as connecting to the network. And the same thing with main, that we're just printing a notification and that is it. Okay, so boot and main, we know what those are, and then we used blinker in the last one. Beeper is the new one. Okay, so beeper is the one that's going to allow us to beep the little buzzer thing there. Okay, let's see, nettools, that is my library for connecting to Wi-Fi. We'll be using that. Microserver, that's a library. Microserver Plus, it's an addition to that library. We'll be using that to parse data. Here's the YouTube API connection that connects to YouTube and gets my number of subscribers and views. Here's a get function for pulling stuff off the network. We'll use that. Of course, there's a replace tool. You should know what that is from the last video, or you can be using the Adafruit or Adafruit or whatever they call that place. You can be using their script to load your stuff. Okay. Now this one is a funny one. Netcreds. I don't want to type in my username and password while you guys are watching, so I made this script. This is a fake one, but anyway, I'm just importing these variables, so I can use these variables and you won't know what they are, right? Okay, so alright, so that's all the things that we will be using. So if we pop open our connection, let's go ahead and connect up to USB 0, and it's ready. import OS, and we'll see what's been loaded. And so there is boot, there's main, there's blinker and beeper, there's the YouTube API if we want to run that, there's nettools, microserver, there's nettools.get, all that stuff. Okay, so it's all there. That is what we'll be using. Now, the first thing we want to do before we do anything related to the network is a hard reset. And the reason is that network stuff happens outside of the main loop that MicroPython is running in. So once you set the stuff up, it's there, it's running, it's doing its thing, it's keeping connected and all of that. It's listening for connections to the socket and all that sort of thing. So even though you interrupt your MicroPython script and you do a reset of your script, it hasn't reset the machine. So let's do a hard reset. Now I could reach over there and push the button, or I could import machine and do machine.reset. Okay, so there's a hard reset. Now let's see if it looks any different when we push the button. So pushing the button, okay, it looks the same because it's doing the same thing. Okay, so now we've done a hard reset. We've completely reset the ESP32. Everything's wiped out of its memory. So now we can do network stuff. Okay, now before we begin that, let me go ahead and import my net creds. Okay, so if I check what we have, yeah, you know what, I should do this. Import everything from net creds. Okay, so now there we have it. There's okay, there's my password, there's my YouTube API key. Okay, so we're good to go. Now we're ready to start doing some network stuff. So import network. Now that is the module that allows us to connect to the network. It's a really nice module. It has pretty much what you need just to, get connected up. Alright, so let's make an object. So we'll do, which is Wi-Fi local area network, and we'll so we use the WLAN class, the Wi-Fi local area network class. Now what we have to tell it is that what we want is a station. That means we want to be a node in the network and connect up to my router, okay, or to a router or something. So we're just a station in the network. We're not the router itself, which would be an access point. We're just going to be a station. So we're going to do network.staif. Okay, so now went through all its stuff that it needed to do, and it's created that object. Okay, there's the object. Okay, so now we can ask it, is it active and running? And it is not, false. So let's make it active and running. And all we have to do is tell it true. Alright, now it's started up and it is running, and that allows us to begin to use it. So the first thing we'll do is do a scans. So we'll use this scan function. Okay, and we just wait a minute and it will return a bunch of stuff to us. So that's hard to read, so let's do this. Alright, let's see what we got. Okay, so these are the networks that it has found, the Wi-Fi networks around here. So of course there's my Wi-Fi network. So that is my SSID to my network, and then this is the MAC address, but it's in hex, so you would have to translate that to be able to read it. This is the channel that's broadcasting on. This is the receives signal strength indicator right there. This 3 right here is it tells us what kind of authentication that it's using, and then false right here tells us that it's not hidden. Okay. Now there's also some other channels or some other networks here. This is a printer, and this is my neighbor. Okay. So we will just connect up to mine. So if I do this, and this is what remember we imported this from my netcreds, my little netcred script. Okay, so we already got that in there. So now we're ready to connect. So let's connect to my network, and I'm going to use my password. Okay, remember I imported that password. Okay, so let's see what happens. Alright, it's doing things, it says it's connected, and it's doing a few more things, and let's just wait and make sure. Okay, now let's do a check. Yeah, it's connected. Okay, now all these functions of course are available in the documentation, so just look at the documentation and see what it has to say. Now here's a key thing that we need to note right there. Okay, 192.168.254.12. That is the IP address that was assigned to the ESP32. So later on, when we set up a server and we want to connect to that from my desktop to the server, we'll have to use that IP address. Okay. Okay, so now we're connected up. Is connected, it's true. Alright, so the next thing we need to know how to do is disconnect. We'll get to getting some information in a minute. Okay, so and then we can do this, ask is connected? No, we're not connected anymore. Okay, now if we want to really turn it off, we have to do this. Okay, now we've got it turned off. It's flushed out, it's turned off. Okay, so if we asked it, is it active? No, it is not active. Okay, so that was, we just went through the process of, we made the object, okay, the WLAN, or the local area network connector object, okay, we made it active, then we scanned to see what was available. All this is right in here. Okay, we scanned to see what's available, and then we connected to my network, and we asked if it was connected. It said it was, and then we disconnected it and we made it inactive. Okay, so we just went through the whole cycle. All right, now let's connect up again. Okay. So I'm just going to use the up arrow. Oh, nope, I'm sorry. First thing we got to do is this. Got to turn the thing back on. Alright, so now we're active again. And there we go. I'm just using the up arrow. And here we go, connecting up again. Yep, picked up the same IP address, which your router will probably, it normally does that. So we ask if it's connected. Yes, we're connected, we're ready to go. Okay, now if we actually want to get some information from the internet using this connection, it's a little bit of a complicated process. So let me pop open this get script, and here's basically what has to happen. We have to make a socket, okay? And then we have to, there's a special way, you have to get some address information, and then you connect to that socket, and then you write your request to that socket, Then you have to set up some polling so that you know when there's data coming back to the socket and you can read it and not get stuck in a loop. Okay, and then once you know there's data, then you've got to read the headers, and then you've got to read the content that is returned, and then you've got to parse the content, and all the while there are a bunch of timing parameters. So in reality, trying to do all this kind of stuff on the command line is not going to work, right? So we need a library. All right, well, in most of the recent distributions of MicroPython, there is a library. Okay, so it's called urequest. Okay, so if we import urequest, what? Oh, yes. How about that? Urequests. Okay, so if we import urequest, then it has a get function. Okay, so well, here's how you do it. So you say the response equals urequests.get, and then we've got to put an address in here. So I'm actually going to let me copy one over here, so I'll have to do all that typing. Okay, this is one of my websites, so this will just get the time. So we're making a request. Now this is going to do everything that you just saw in that wget script. Okay, it's going to make a socket, it's going to get the address information, it's going to connect up to the socket, it's going to send the query, and then it's going to read the data back and all that sort of stuff. Okay, so here we go. And there we go. All right, now it creates this object R, which is the response, so we just ask it for r.content, which is a variable. Okay, and there's the content. Okay, so it was just giving us the time right there. So there's the content, and of course we notice that it is in bytes. Okay, so what we've done now is we have connected to my local Wi-Fi network. We've been assigned an IP address. We've imported this request library. We've made a GET request to Simple Design to get the current time on the server. And we got the response back, and we asked for the content of the response, and there it is in bytes right there. Now, of course, that's when we would do something with it, right? Okay, and then what's left to do is disconnect. Now you don't have to disconnect if you're using, actively using the internet, but if you aren't, there's no reason to stay connected and use the extra power and all that kind of stuff. And then once we disconnect, we also want to just go ahead and turn everything off. Okay, so now we've gone through the whole cycle. Made the object, turned it on, made it active, connected, or we did a scan earlier, and then we connected to a network, and then we used the urequest library to send a GET request. We got some data back, we looked at the data, then we disconnected, and then we made it inactive. And there we are. So those are pretty much the built-ins that you have. Okay, now you can use them like we did to create a station. You can use the same type of built-ins to create an access point. But anyway, just go to the documentation and check out the other functions that might be there. But that's your basic stuff. Okay, so next we'll start looking at some libraries. Alright, the first library I want to talk about is nettools. And it's just a simple library that takes everything that we were doing with the built-ins and it packages them together, does everything for you. Just makes it easy, right? So when you import it, it's going to try to kill everything, and then you can use a scan function to see what's available, and then simple connect using your SSID and your password, and then the disconnect using nothing, right? So that's all you've got to do. So let's have a look at it. Actually, let's just import everything. Okay, so we've imported everything, and then we can just use the functions. You'll see why I like these better. So it's scanning and it prints it out. So we've found 3 access points, the same 3 that we found earlier, mine, my printer, and my neighbor. Okay, now it goes ahead and it translates the MAC address. So it translated it from hex into ASCII, which you can read. It also translated the encryption type for you, so that you can see that and read that easily. Okay, so that's really easy to do. And then you can just call the connect function. I'm using the variables that I imported from the netcreds script. And there we go. Alright, so we're connected and it returned true, and it gave us the same IP address as last time. So that's it. We scanned, we picked one, we connected, and then we can just disconnect if we want. And it disconnected. And the thing is, when you connect, it makes it active. When you disconnect, it makes it inactive, so it turns it off. So those are the 3 functions. Very simple to use, and you know, that's why I have the library. The next library I want to talk about is my wget function. Now, this is named, of course, after the Linux, get request function. But anyway, so this is a lot like urequest, which comes with MicroPython. It just does a few extra things that I want. So it gives you the opportunity to give it an out file or a file name, and it will write it to that file. You can show the data or not show the data as it gets it, and you can have the data returned to you. And nice thing, you can tell it how much data you want to get, because with the limited memory, some websites you may not want to get on there and try to get all the data off of it, because it could overwhelm your ESP32. Okay, but it's essentially works the same way. Okay, so we'll just import it. Okay, but now what we do have to do is connect up. Alright, so let's go ahead and reconnect. Give it a second. There we go, we're reconnected. And then we can just use the wget function with its built-ins, and we'll get the same data. Okay, so there we have it. It was printing to the screen as we went. It had the show data feature. So here we get to see all of the headers. Okay, there's the headers, and then here is the data link, and there's the data right there. Okay, now if we wanted to collect that data, we could do this. Okay, and then there's the data. There's the headers. Okay, so we could do it that way. Now, one thing about these, which is nice, is they will handle HTTPS in a limited way. So now you would think with that very small Google simple Google page there wouldn't be much data, right? Think again. There's a lot of data. Okay, look at that stuff. That's all from that. Anyway, but that is an HTTPS page, so it handles that as well. Okay. Now, once we do that, then we disconnect. Whoops. Okay, now that disconnects. It also makes the radio inactive. Okay, so good to go. Okay, now we can look at the YouTube API because it uses wget. Okay, so basically what is happening is this is something you could just import from main and it will start running. Okay, so it's importing all the stuff we need. It imports nettools because it uses the connect and disconnect. It imports wget because that's what it's using to query the Google API. Of course, it imports my credentials. Okay, and then it also uses blinker and beeper because that's how it's notifying you that it's actually doing something. Okay. Let's see, and then it garbage collects. We connect up, and then it goes into a loop. And what it's doing is every 60 seconds, it is coming down here, and here it is. It makes this big query, and then it gets the data. It parses the data out, and it checks my subscriber count. It's JSON data that's returned. So I have this JSON decoder right here. UJSON comes. It's a built-in. So it decodes the JSON data, and it looks for my subscriber count. If my subscriber count changes, then it beeps at me. If it goes up, it goes bzz. If it goes down, it goes bzz. Okay, and now if the view count changes, then it beeps one time for every change in the view count, and it gets higher and higher. Now, Google doesn't update their stuff, but about every 30 minutes to an hour, okay? Around 45 minutes most of the time is when you get changes. So it doesn't happen all the time, okay? And then it prints out what views and what subs we have, okay? So this is a full-fledged thing. So all we have to do is import it, and it will just start going, okay? Okay, I'm just going to do a soft reboot using Control-D, and then that's just to clean everything out. And I'm going to import YouTube API, and this is just going to do the whole thing. Okay, so it's connecting up, it's connected. There's our IP. You heard the beep. The beep says that it checked the YouTube API. So we started out with 3230 as subscribers and this number of views. Okay, and then it's just going to wait for about a minute. I don't have it timed accurately. It's going to wait for about a minute. It's going to go through the same routine. It's going to check the API, and if there's any change, it's going to beep out the changes. Alright, we're about to do it again. And sadly, there were no changes. The truth is, YouTube only updates about every 45 minutes. Sometimes a little before that, sometimes a little longer, up to an hour. But about every 45 minutes, the counts and the users, that will update. So you kind of have to wait for that. But anyway, that's what this does. So you can use this for your own channel. You'll have to get a key though, so you'll have to look up how to get a key for the YouTube API. Alright, now we're ready to talk about microserver. So let's just open it up here. Now, basically what a server is so the ESP32, we're going to connect it to the network, and it becomes a node or a station on the network. And it's going to set up a socket, and it's going to listen on the socket. Now when a request comes in, It's going to get the data from that request. It's going to send it to a function. It's going to do something, and then it's going to send something back to the socket so that it goes back to whoever made the request. Usually that's some HTML data, right? Okay, so that's basically what we've got set up here. So we have this class called microserver. Now the first thing we notice is that there's this application. So when the server gets the request, it's going to send all the information it gets to this application. Now this is the default application. We'll replace this application with what we want it to do. Okay, but so then here when we tell it to serve, it's going to go into an infinite loop. Okay, it's going to bind to a socket. Here's where we're binding to the socket, and then once we're bound to the socket, it's going to loop, and it's going to wait for a request to come in on the socket. When the request comes in on the socket, it's going to collect that information, and then in this block, what it's doing is it sends the information out to the application that we defined. Now the application, in this case, it has to be an iterator. Okay, so we're iterating through the blocks of data that come back from the application, because we're sending them the information we have, and then we are writing that stuff back to the socket. Okay, and then once we've written it all back to the socket, then we close that particular client socket, we clean everything up, and we go back into the loop and get ready for another request. And that's all that this server's doing. So it's just listening. When it gets a request, it sends it to application. Application is going to send back blocks of data. It should be bytes of data. In this case, we're sending it back a little bit of HTTP, and then the server is pushing that back out to the client. Okay, and in our case, the client will be a browser. So that's what we'll use to communicate with this thing. Okay, now so that's the basic server. So what we've got to do now, and which I've already done, is we have to redefine our main script. So our main script now has to do some work to get everything set up and get the server turned on. Okay, so here's main. Here's our new main script. So we're doing some imports. We're going to import beeper because we're going to beep when there's a connection. Okay, here we're importing nettools. Here's my credentials to connect up. Here we're importing everything from microserver. We do a garbage collect after we do our imports, just to clean our memory. Okay, now here is the application that we've defined. So we're going to get the socket, and we're going to get the address that it came from, and how many clients have connected. That's what's going to come into this thing. So when we get that information, we're going to beep, and then we're going to make a little, this is a little bit of HTML. Oh, well, actually, no, we're going to send it, we're sending it as plain text. Okay. So we're making a little bit of plain text, and then here we're making this response, and then we're yielding it back because it's an iterator. So we're sending it back block by block. Okay. So we're just going to say your client number so and so from this such address. I beeped at Clayton, and then these are the headers that we're putting on it. We're going to put content length, content type, plain text, and the HTTP header, and then we're just going to send it back. Okay, so that's what our application does. It's just sending back a little data. Okay, so now we're here's the connection, connecting to the Wi-Fi. We're making the server. Now once we make the server object, here it is, then we have to redefine the application. So we're saying that the server application equals application, which is this application. Okay, so we're redefining what the server application is, and then we just tell it to serve, server.serve, and it puts it in that infinite loop, and it just keeps on serving. Alright, so let's try it out. Okay, I'm going to do a soft, actually, so I've uploaded main and it's ready to run. So all I'm going to do is a soft reboot by doing Control D, and it's going to set itself up. Okay, so we're doing the connection. There's the connection. Okay, we got to watch the IP. So here's the IP. This is the IP on the local network. So we need that to connect to it. And then here's a notification from the server. So it's listening for one connection. This means this is just localhost, okay, and on port 80, which is HTTP. Okay, so let's pop open our browser. Now I've left this open down here so you can see what it says right there. Okay, so we want to go to 192.168.254.12. Okay, now remember, when a browser makes a request, it requests the page, and then it also will request the favicon, you know, the icon that goes right up here. That's why you heard 2 beeps, and if you look down here, you see that we have 2 requests have been sent in. Okay, so there now, client 1 came from this address. This is my local address. Okay, this is the address of the ESP32, but this is my desktop address on the local network, and it just says I beeped Dick Clayton. Now, if we hit refresh, okay, now we're client 3, and you heard it beeping again, right? And so we got 2 requests again because the browser is requesting the icon. Okay, browser didn't request the icon that time. Okay, so that is the basic idea of a server. So at the browser is the client, you get the address, you send it out. Now, if you were wanting to work from outside of your home network, then you're going to have to set your router up to forward these requests to the ESP32. Okay, but this is the basis of it. Once you know the address, then you send the request, and the server gets that information. It does what it's supposed to do, and it sends something back to you. And that's exactly what we're doing here. Okay, very simple. It's a fixed thing. We're not parsing any data. We're not doing anything. All we're doing is when we get a request, we don't care what kind of request it is. Okay, that's what, you know, with microserver, we're not asking, we're not doing anything. Our application is not complicated enough that we are parsing out the data or anything like that. We're just, well, actually it's in main, isn't it? Okay, so this is what we're doing. We're just, whatever comes in, whether it's a request for an image or anything else, we're just beeping, and we say, hey, I beeped it, Clayton, and that's it. Okay, now we'll get to a more complex application in just a minute. Okay, now we're going to kick it up to the final level and look at MicroServer Plus. And this is going to let us do some real, we'll make a real server here. Okay, so what does MicroServer Plus do? Well, basically it is for parsing the data that comes in. Okay, so we create a parse class, and then we ask it to get data, and we give it the client socket, client address, and all that sort of stuff. So we give it that stuff, and then it gathers the data, so it sets up a poller so that it can get the data without crashing. Okay, so it gets the data, it gets all this query data that we need, and it parses it out, and it even, if we go down here, it even takes the escape characters out of the URL. So, well, it does a limited set of them, so it does this set of escape characters. It pulls them out of the URL. So that allows us to actually get real data from the request that's coming in from the client. Okay, so we're just going to add this to the server that we have. Okay, so let's pop open main. Okay, and here is main right here. Now from this line up, it's all the same as the last time. So we're just importing things. We're importing nettools, creds, import microserver, and we do a garbage collect. I really ought to move this garbage collect down to below here, but we won't worry about that. Okay, and then way down here, past this line, everything is the same. So we're just connecting to the network. We're starting the server. We're defining the application of the server, and then we're just telling it to serve forever. We're not. I mean, we're defining the server, making the server object, defining the application, telling it to serve, and it goes into the serve loop. Okay. Now, here is the application that we're defining. Okay. So the big thing that we're doing is that we're using the parser, which let's see. Okay, so importing the parser, making the parser object. Okay, and then in our application, we're getting the query data from the parser. So the parser's it's getting all that data out, it's putting into a dictionary, and then we're getting out text 1. I'll show you where that comes from. It comes from a HTML form. Okay, so we're getting that, and then we're formatting the output data. We're sending the output data, and then if there was text in the input data, then we're going to play some beeps. Okay, we're going to play that music using this beep play function. Okay, all right, so let's go on up. Oh, here's the beep play function. Basically, we've got notes. So if you give it notes and a duration, or it equals out to a frequency and a period, then it'll just beep that using the beeper function. Okay, so it's just splitting those lines up. It's looking for a frequency, it's looking for a period, and then it's just going to use the beeper function on pin 12 to play the frequency for the period. Okay, so that's what that is. And then the last part of it is this HTML form. So this is just an HTML document, and it's got some style, some CSS style in there, and then here's the form. Okay, it's really just a big text area that is named text 1, and when we hit submit, then it posts it to the ESP32 server. Okay, so that's all the parts. So basically what's going to happen, we're going to turn the server on, we'll connect to it, it will give us this form that we defined. Okay, we'll put in some notes for it to play, we'll hit submit, and it'll parse that data out of there. You'll get that text that we sent it, it'll send us back a response, and then if there's any text that it can recognize, it's going to play it. Right? Alright, let's try it out. So let's see, we'll close this down, and I'm just going to do a soft reboot. Okay, there's our IP, and our server is running. Okay, so pop open the browser. 192.168.254.12. Ta-da! Okay, so here is our form. It's the ESP32 beeper input. There's our form. So if we put a note, now remember when we looked at main, how we defined main, we had these notes that we can use. Okay, so let's just try. We'll just try some of those notes. So if we just put in A and we hit go, did you hear that? You might not. Let me move this over closer, make sure you can hear it. Okay, heard A, B, C, D. There we go. Okay. Here now I'm going to copy and paste and put all the notes we can play in there. Well, not all of them. I won't put the sharps and flats in. Alright, so here we go. You ready? Okay. I'm pretty sure you can hear that. Let me raise this up next to the speaker, or next to the mic. Okay, I'm just playing that on the beeper. Alright, now if we want to play some music, then the way we set that up to parse, we can say A, and then we can put a period in there. So let's say, 4 beats. Okay. So it played it for a long time. Let me hold this up where you can. Alright, so it played it 4 beats worth instead of the default 1 beat worth. Alright, now you want to play a song, I know. So I have already prepared. Let me copy it. AXEL F, right? Because it's the song we play. So here's the note and the period, or how many beats to play it for. Okay, so there's all our notes, how many beats to play it for. Sounds like I got a note off there somewhere. Okay, but what I'm trying to illustrate is that now we can do functional stuff. So we can, we've got our server down here. We define our application. Now we can have sub-functions to the application. We can do all kinds of stuff and make a real thing. So you could set up a weather station, a weather server, whatever. You could set up home automation, whatever you need to do. Alright, so that is pretty much it. So let's end with AXEL F. There we go. And in case you were wondering, there's the that's the input that we sent in right there. All right. Okay, that should be enough to get you going. So go do some cool stuff. All right.